Azure Monitor provides a centralized platform to observe and manage diverse telemetry data. After configuring foundational settings, including diagnostic and activity logs, you can refine the scope of your analysis. By selecting specific Azure resources or entire resource groups, you gain flexibility in how data is gathered. In prior steps, you explored setting up log configurations and examined performance metrics. Now, you can adapt those insights to determine which logs enrich your troubleshooting or optimization efforts. Select resources carefully to avoid unwanted data. Use naming conventions that match your organizational structure. Filter logs based on critical components to prioritize relevant events. A cornerstone of log exploration in Azure Monitor is the Kusto Query Language, KQL. Its syntax is designed to be expressive yet efficient, enabling you to retrieve and manipulate large datasets stored in log analytics workspaces. With essential keywords like project, where, and summarize, you can quickly distill massive records into figures you can interpret. KQL also supports regular expressions, windowing functions, and joins, ensuring advanced analysis. Understanding how data is organized in tables and columns is critical. Familiarize yourself with basic query operators. Explore official KQL documentation. Practice with sample queries in a test environment. Constructing queries involves referencing tables that store events and logs, then filtering them to show only what you need. For example, to search for exceptions in an application insights table, Kusto exceptions were timestamp, ago, 1D, project timestamp, message, operation of ID order by timestamp desk operators like wherein project isolate relevant data and control display columns. Sorting by timestamps provides chronological insights. By incrementally refining parameters, you can uncover meaningful trends. Start with broad queries and then narrow your search to specific time frames, resource IDs, or custom fields to gain clarity on system issues. Beyond filtering, KQL supports conditional operations that let you segment data dynamically. For instance, the case function allows you to define outputs for different conditions within the same query. Kusto security event extend access level equals case. Event ID equals 4624 logon. Event ID equals 4625 failed logon. Other such assignments help group records, making patterns more apparent. Conditional logic can also drive custom alerting by classifying the severity of various events. Integrating conditions into queries aids in building automated responses, enabling teams to take targeted action when specific thresholds or critical statuses occur within monitored systems. Once you have filtered your data set, the next focus often involves aggregation. With features like Summarize, you can calculate averages, minimums, and maximums across columns. For service performance checks, metrics such as CPU usage or request counts can be grouped by intervals. Kusto perf where object name equals processor summarize average, counter value, by bin, time generated, 1H. By segmenting data into 1-hour windows, you observe performance over time. Additional grouping fields, like region or instance name, reveal divergences in different resources. Effective aggregations reduce volumes of raw data into digestible numeric insights, a vital step before visualizing logs or building predictive models. Translating query results into charts or graphs can highlight trends and anomalies. In Azure Monitor's query interface, you can toggle between table results and various visualizations, such as line, bar, or pie charts. For series data, line graphs help track fluctuations over a timeline, while stacked bar charts can segment multiple categories. This visual context is often essential in capacity planning or incident analysis. By identifying spike patterns in CPU usage, for example, teams can correlate them with deployment events. Visual methods also make it easier to share insights with non-technical stakeholders, fostering quicker decision-making on resource changes. To manage substantial data streams, custom dashboards can consolidate visualizations and queries. Azure supports pinned insights from log analytics workspaces onto shared dashboards. These can combine real-time system status, network health indicators, and potential security alerts. By presenting multiple panels in one interface, you create an at-a-glance summary of your environment for operations teams. Configuration typically involves saving your favorite queries, refining their time ranges, then embedding them in a tailored layout. Adding filters or drop-downs makes these dashboards even more interactive, allowing colleagues to adjust timescales or shift focus to different resource groups in a single view. Complex issues sometimes demand deeper analysis beyond simple metrics or error counts. Using KQL's join features, you can correlate data from multiple tables, such as matching virtual machine events with associated network security group logs. This cross-reference helps pinpoint if connectivity problems coincide with CPU spikes or database timeouts. You can also apply time-based operators like union for a broader perspective of simultaneous events. Advanced troubleshooting techniques may include anomaly detection plugins, where Azure Monitor flags deviations from historical norms. These approaches help isolate subtle lifetime patterns or recurring situations, further enhancing proactive monitoring and corrective action strategies. Logs from various Azure services, including Azure Security Center and Azure DevOps, can feed into Azure Monitor's log analytics workspace. This unified approach streamlines correlation, as you can query resource utilization, security alerts, and build pipeline statuses together. You also gain synergy with services like Azure Sentinel for more robust threat detection, or with Power BI for advanced data modeling and bespoke reporting. In addition, alerts configured in Azure Monitor can initiate logic apps, automating tasks like sending notifications or spinning up new instances. Such integration ensures your environment remains continually observed, aligning with best practices for efficient cloud administration.